Before we can even begin to grasp the secrets at the edge of the universe, we need the right tools for the job. NASA's quest to map the cosmos starts with a fleet of remarkable instruments, each designed to capture the faintest whispers of light from the farthest galaxies. Space telescopes like Hubble, the James Webb Space Telescope, and the Chandra X-ray Observatory peer across vast distances, using advanced sensors to collect data in wavelengths invisible to the human eye. These telescopes act like time machines, allowing scientists to observe the universe as it was billions of years ago. But gathering data is just the beginning. NASA's teams rely on sophisticated data analysis techniques, including artificial intelligence and machine learning, to sift through staggering amounts of cosmic information. Algorithms help identify distant galaxies, map their positions, and even estimate their ages. Yet the challenges are immense. Observing objects billions of light-years away means dealing with cosmic dust, interference, and the ever-present background radiation left over from the Big Bang. Even the most advanced instruments must be painstakingly calibrated to filter out noise and reveal the true structure of the universe. Through a combination of cutting-edge technology, tireless innovation, and creative problem-solving, NASA continues to push the boundaries of what we know about our cosmic neighborhood and what lies beyond. As NASA's cosmic maps grow sharper, the implications go far beyond dazzling images and record-breaking discoveries. Each new piece of data is rewriting our understanding of the universe and our place within it. For cosmologists, these revelations mean rethinking some of the most fundamental questions. How did the universe begin? What is it made of? And how will it end, if ever? The recognition of a vast, interconnected cosmic web, woven from both visible matter and mysterious dark matter, challenges old models and sparks new theories about the architecture of the cosmos. The precise measurements of dark energy's effects on galaxy clusters are forcing scientists to reconsider the ultimate fate of everything. Will the universe expand forever, tear itself apart, or someday collapse back in on itself? But the impact stretches even further. These discoveries are already shaping the next generation of space missions. With every new insight, NASA and its partners can design telescopes and probes with more targeted goals. Whether it's searching for the first stars, mapping the distribution of life-essential molecules, or hunting for the signatures of other civilizations. Missions like SphereX and the Roman Space Telescope are being tailored to answer questions we couldn't have even imagined a decade ago. And it doesn't stop with the experts. As our cosmic horizons expand, so do the possibilities for future exploration, robotic and eventually, human. The clearer our map, the more strategic our journeys can become, whether we're probing the edges of our solar system or plotting a course for interstellar travel. Each discovery is a stepping stone, guiding us toward new technologies, new missions, and new ways of seeing ourselves in the universe. Ultimately, these findings remind us that science is never static. Every answer leads to more questions, every map reveals new mysteries, and as NASA continues to push the frontiers of knowledge, we're not just charting the cosmos, we're shaping the future of exploration, discovery, and our own cosmic story. Headline: NASA just revealed the edge of the universe, and it's nothing like we thought. Sounds wild, right? But what's actually going on, and why are so many headlines making such a big deal about it? Let's dive in, because the truth is both more subtle and more inspiring than any clickbait title. So here's what's really new, and what NASA isn't actually saying. First up, there's no actual physical edge of the universe that anyone has found. You can't send a probe past a cosmic fence and suddenly see a big end of universe sign. The universe, at least as far as our best theories and observations go, is either boundless or so vast that any edge is way, way beyond what we can see. What's new though is the way we're mapping and measuring what's out there. And that is changing the way we see the universe, almost literally. Thanks to new technology and innovative missions, we're now able to peer deeper into space and further back in time than ever before. Let me break down the latest discoveries because the details are where the real story lives. First, you've got New Horizons. Yeah, the same spacecraft that flew past Pluto. It's now so far from the sun, it's helping scientists measure the faintest glow in the universe, the cosmic optical background, or COB. The COB is essentially the sum of all the visible light ever emitted by stars and galaxies throughout cosmic history, even those too faint or distant to see individually. Because New Horizons is out beyond the glare of our own solar system, it can measure this cosmic glow with unprecedented accuracy, free from the interference of sunlight and dust that plagues Earth-based and near-Earth observations. Now the James Webb Space Telescope, JWST, has been pushing the boundaries even further. JWST is the most powerful space telescope ever built, designed to observe infrared light, which allows it to see through cosmic dust and peer back to the earliest galaxies formed after the Big Bang. Think back to the Hubble Ultra Deep Field. JWST revisited that same patch of sky and spotted something like 2,500 new, extremely distant galaxies, some dating back over 13 billion years. It's like turning up the brightness on the universe and seeing details we never even imagined, galaxies forming, merging, and evolving in the cosmic dawn. And get this, NASA's got more missions coming, each with a unique scientific focus. SphereX, launching soon, will scan the entire sky in infrared, mapping the distribution of water, organic molecules, and the large-scale structure of the universe. The Roman Space Telescope, with its enormous field of view, will create 3D maps of millions of galaxies and help unravel the mysteries of dark energy and cosmic acceleration. Think of it as building a cosmic atlas, not a flat map, but a living, breathing, three-dimensional view of our universe on the grandest scale, revealing how galaxies cluster and evolve over billions of years. So, if you're seeing headlines about NASA finding the edge, it's not about a wall or a border. It's about clarity, about seeing the universe in ways we never could before. It's about finally being able to see the universe in finer detail, with more depth, and with unprecedented precision, measuring the faintest glows, the earliest galaxies, and the structure of space itself. Now here's where it gets really cool. Astronomers are also rethinking the architecture of the cosmos. All these better maps and deeper views reveal a vast, interconnected web. Galaxies are strung together by filaments of dark matter and gas, separated by enormous voids. This cosmic web is the scaffolding of the universe, shaped by gravity and the mysterious influence of dark energy. Its cosmic structure on a scale that's almost unfathomable, clusters of galaxies forming nodes, filaments stretching for hundreds of millions of light-years, and voids so vast they defy imagination. But even this cosmic web exists within what we call the observable universe, the region of space from which light has had time to reach us since the Big Bang, about 13.8 billion years ago. That boundary isn't physical, it's just as far as light has had time to reach us. Beyond that, the universe may go on forever, or it may curve back on itself in ways we can't yet detect. So to sum it up, NASA hasn't uncovered a literal edge of the universe. What's actually new is the sharpest, most detailed map of what we can observe, expanding our cosmic horizons without bumping into a border, and revealing the universe's structure in ways that were impossible just a decade ago. It's not about finding an ending. It's about seeing more, understanding more, and getting closer than ever to the true scale and beauty of the universe, thanks to the combined power of missions like New Horizons, JWST, SphereX, and the Roman Space Telescope. If you see an eye-popping headline or viral video saying otherwise, take it with a grain of cosmic dust. Science is about pushing boundaries, yes, but mostly it's about clarity, patience, and precision. Every new mission, every new map, brings us closer to understanding our place in the cosmos. If you find a source or a claim you're curious about, send it my way. I'll gladly dig in and help separate the real discoveries from the internet hype. Because honestly, the universe is amazing enough, no sensational headlines required.